Hey guys, welcome to 12.1 day 3. We've talked about limits in the past two videos, and today we're going to talk about a different component of them. So we talked about limits as x approaches c, right? We kept saying as you approach x equals 2, x equals -1, x equals 0. Well, today we're going to talk about what happens or how you find limits at infinity. Okay, so if the value of f of x approaches a finite number as you move to infinity, we say the limit is L. Right? So what we're going to do is we're going to look at the end behavior. So when we talk about limits at infinity, we're talking about end behavior. And we've talked about that before in different terms. We actually even used, the similar terminology. Remember we used to say as x approaches infinity, f of x approaches blah, blah, blah. That's what we're going to talk about. So if you move further and further and further to the ends of the graph, to the very right end and to the very left end, what y value is the graph approaching? All right, so let's take a look at a couple of examples and then we can call it a day. Look at example A here. I have the limit as x approaches infinity of 1 over x to the 4 minus 3. So again, this is the function f of x, and it's graphed here. And I'm looking at what happens as x approaches positive infinity. So as I go to positive infinity here, as I go further and further and further out, look at the graph. If you want, trace the graph with your finger or with your pencil and see what is happening as you move towards the very right end of this. And you see here that this graph is leveling off at y equals -3. So we say the limit as x approaches infinity is -3. And that's just end behavior. When we have x equals infinity or negative infinity, that's just end behavior. What we just found here was the right end behavior. And you've been doing this since algebra 2, so you're used to that. Here, we're looking at the limit as x approaches negative infinity. So as I move to the opposite side, and now this is the left end behavior. So as I move to the negative end of this, my graph is approaching a y value of -3. So I say it's -3. Okay, now this is not like, we look at it from the left, we look at it from the right. If it's -3, then we say the limit is -3. So remember, this is a very, very different situation. Before, we had one x value here, and we were approaching that value from the left and the right. Well, that's not what we're doing here. Now we're going into opposite sides of the world. Okay, so we don't say, oh, okay, then the limit is -3. No, these are just opposite, left end behavior, right end behavior. Okay, let's do another one here. We want to find the limit as x approaches infinity of sine of x. Okay, well, this is sine of x. And what happens as I move further and further to the right, to infinity? This is going to keep oscillating, right? So what do I know? I know that the y value is going to be somewhere between -1 and 1. Now, do I know where infinity is? I don't. Do I know where this stops? I don't, right? Because it is uncertain, then I say this does not exist. Okay, so what about the left end behavior? The limit of sine of x as x approaches negative infinity. Well, is that situation any different? I still don't know whether it's going to be up or down or at 0 at negative infinity. So that's also dne. And last but not least, take a look at this beautiful function. This is e to the x sine 3 pi x. So what we have here is an exponential multiplied to a sinusoidal function, and that's what it looks like. We're looking at the limit as x approaches infinity, right? So as I move to positive infinity to this side, well, what's going to happen here? This is going to keep oscillating up and down, up and down, up and down. And because it's oscillating, I don't know where it's going to end up. So this is dne. Now, look at the opposite side though. What happens to the limit of this function as x approaches negative infinity? Now, if I move over this way, what's happening to the graph? What y value is it approaching? It looks like it's flatlining, right? To y equals 0. So we say the limit from that side is 0. Okay? All right, and that's it for today. Good luck with the homework.